Ever wondered why your room gets messier the more you use it, but never the other way around? This is entropy in action. Now you might be asking, what is entropy? Well, think of it as a scientific measure of disorder or randomness in a system. It's a bit like the number of ways you can rearrange the stuff in your room. The more ways you can do it, the higher the entropy. But here's the interesting part. Entropy ties into the second law of thermodynamics. This law, a cornerstone of physics, states that the entropy in an isolated system, like your room or even the universe, can only increase over time. So that mess in your room, it's not just about your cleaning habits, it's a fundamental law of nature at work. Every time you use your room, it's likely to get a bit messier. Simply put, entropy is the universe's trend towards chaos. Now, let's delve a bit deeper. What really happens when entropy increases? Picture a deck of cards. When you shuffle it, you're not trying to arrange it in a particular order, right? Instead, what you're doing is increasing the deck's entropy. The deck has a higher entropy when it's shuffled because there are so many more ways it can be arranged. In the realm of physics, entropy is a measure of the number of ways a system can be arranged, or the number of microscopic configurations that a system can have. The more ways a system can be arranged, the higher its entropy. Now imagine a pile of sand. Each grain of sand can be in many different places, leading to a vast number of possible arrangements. The pile doesn't care where each grain of sand is, all it cares about is that it's a pile. So, any arrangement of grains that still looks like a pile is acceptable. This is why a pile of sand has such a high entropy. There are so many ways it can be a pile. But why does a system tend to evolve towards states with higher entropy? Well, it's all about the probabilities. States with higher entropy simply have more possible configurations. So it's far more likely for a system to be in one of these states than in a state with lower entropy. This is why when you shuffle a deck of cards, it's incredibly unlikely that you'll end up with all the cards in order. There are just far more ways for the cards to be out of order, and this is why your room tends to get messier over time, rather than cleaner. There are just so many more ways for your stuff to be scattered around than neatly arranged. But don't despair. While the universe might be on a one-way trip towards maximum entropy, we can still find order in the chaos. It's just a matter of understanding and working with the probabilities. So, the increase of entropy is all about the probabilities. Entropy is not just a scientific concept. It has profound implications for our understanding of the universe. The principle of increasing entropy is an invisible hand that guides a myriad of phenomena. Imagine a bottle of perfume being opened in a room. The scent doesn't stay confined to one corner, but spreads throughout the room. This is entropy in action, driving systems from a state of order to disorder. But entropy isn't just about spreading scents or mixing sugar into your coffee. It's also about the grand cosmic events. It's about the ultimate fate of the universe. Ever heard of the term heat death? It's a theoretical state, a point of maximum entropy, where the universe has been used up and no useful work can be performed. In essence, entropy dictates the flow of time and the destiny of the universe. It's a fundamental principle that governs not just our daily lives, but also the vast cosmos we're a part of. So, what have we learned about entropy today? We've journeyed through the fascinating world of entropy, a measure of disorder or randomness. It's an invisible, yet omnipresent character in the grand drama of the universe. We've discovered that entropy isn't merely a scientific concept, but a fundamental aspect of our reality. It's the unseen hand guiding everything from a coffee cup cooling on your desk to the vast cosmic dance of galaxies. We've learned that entropy tends to increase over time, a principle that influences a wide range of phenomena. It's the reason why ice melts, why your coffee gets cold, and why your room gets messier the more you use it. It's also the key to understanding why time only flows in one direction, and why things change. Remember, entropy is not just a scientific concept, but a fundamental aspect of our reality. It's the reason why time flows, why things change, and why your room gets messier the more you use it.